Systems problems. Example 1. We're at a dog show where there's 80 dogs and people. So total of dogs and people are 80. And you have been told that there's 266 legs at the show. How many dogs and people are there? So whenever we do these word problems, it's good to read that last sentence because that helps us establish what our variables are. So we're going to let x equal the number of dogs and y equal the number of people. So we have two variables, so we have to come up with two different relationships. So one of the relationships we're going to get is the 80 dogs and people. So dogs and people are going to be x and y, or the number of dogs and the number of people, and together they're going to add up to 80. So there's one relationship, x plus y equals 80. The second relationship we're going to use is the 266 legs. Well, each dog has 4 legs, so we're going to do 4 times the number of dogs, x, for the number of legs from the dogs. And since people have 2 legs, we're going to do 2 times y, and that's going to give us the 266 legs. Once we set up our variables and set up our equations, we can now just solve this. Now we're going to solve this. In this case, we're going to do this with substitution. So I'm just going to substitute. I'm going to say y is equal to 80 minus x, and then I'm going to replace the y in equation 2. So I'm going to have 4x plus 2 times, and instead of y, we're going to use 80 minus x, and that's going to be 266. We're going to expand these brackets and combine our like terms, so 160 minus 2x equals 266. So we end up with 2x, or 2 times the number of dogs, is going to be equal to, we're going to subtract 160 from both sides. So we end up with 106. So the number of dogs is going to be 53. So if we have 53 dogs, then y, the number of people, we can solve by plugging back into equation 1. So x is 53. The number of people, y, is then 80 minus 53, and that gives us 27 people. Okay, so then we can say that number of dogs equals 53, and we can say that the number of people equals 27. In this next problem, we have a mixture problem. So we're going to mix 5 liters of 30% juice and 3 liters of 20% juice, and we're going to calculate the percentage juice that we end up with. When we do this, what we can do is we can figure out the amount of total juice from the 30% juice. So we're going to do that by doing 30% times the 5 liters. And then we're going to figure out the amount of juice from the 20%. And to do that, we're going to do 20% times 3 liters. And that's the total amount of juice. Now, what we can do then is we can divide this by the total volume, and that's going to give us the percentage. So the parts of juice divided by the total volume is going to give us the percentage juice. So in this case, the total volume is going to come from 5 liters of the 30% plus the 3 liters from the 20%. Okay, so when we do this calculation, we end up with 1.5 plus 0.6 divided by the total volume of 8. So we get divided by 8. That's going to give us 2.1 over 8. And when we work out this percentage, 2.1 divided by 8, that's going to give us 26.25%. Okay, so it's 0.2625, so 26.25%. For B, we're going to do the same calculation. We're going to take the $5 per kilogram fertilizers to figure out how much that costs in total. So we're going to take the 20 kilograms of $5 per kilogram. So we're going to do 20 kilograms times $5 per kilogram. And we're going to find out the total value of the 45 kilograms of $2 per kilogram. And so that gives us 45 kilograms times $2 per kilogram. So that's going to be $90. So we're going to end up with $100, $190 total. So that's going to be $190 total. And that's going to be over 65 kilograms. So we're going to have 20 plus 20. I'll do this in colors here. It's going to be the 20 kilograms plus the 45 kilograms. So we have a total of 65 kilograms in total. Okay, so it's $190 divided by 65 kilograms, and that's going to give us 190 divided by 65 gives us $2.92 approximately cents per kilogram. Okay, so this is how we do our mixtures. We can calculate the percentages this way. We're going to now look at this and solve this in the next problem. We're going to solve for the parts of this in the next set of problems.